The Southwest Regional Partnership on Carbon Sequestration is one of 7 regional partnerships created by the Department of Energy's National Energy Technology Laboratory. These partnerships are charged with regional research and development of safe and permanent storage of carbon dioxide, also known as CO2. Carbon storage is part of an effort to combat climate change through lowering carbon emissions released into the atmosphere. Underground formations for CO2 storage include oil and gas reservoirs, unminable coal seams, and deep saline formations. The Southwest Partnership has developed and implemented many methods to ensure the safe storage of CO2 in these formations. These techniques include instruments that monitor CO2 in storage spaces to determine movement as well as changes in physical and chemical states. We also use various models to predict movement, chemical reactions, and permanence of CO2 storage in the formation. This film introduces some of the methods being implemented in the Southwest to make sure that underground storage is a viable and safe option for minimizing the problems brought about by climate change.
We're here in the southwestern United States, and most of the rock formations that make up the landscape here are actually desert type of rocks. They're Aeolian sandstones that make these great, beautiful brown and red, relatively massive rock formations like things you see in Monument Valley.
Geologists like Mike are researching safe ways to store CO2 in existing spaces in various rock formations throughout the Southwest. He is just one member of the Southwest Partnership composed of a diverse team of experts in geology, engineering, economics, public policy, and outreach, charged with evaluating available technologies to store CO2, one of the leading greenhouse gases contributing to climate change.
We're interested in how we can practically monitor where the CO2 is going.
And so if we can find ways to take CO2 out of the atmosphere and store it away forever, then that would help.
By preventing CO2 from being released from coal-fired power plants, hydrogen plants, cement plants, and other such industrial facilities, the American Southwest could greatly reduce its carbon emissions from stationary sources, which contribute up to 56% of our total greenhouse gas emissions.
Here at Aneth, we're injecting pressured CO2 to enhance the recovery of the oil.
The Southwest Partnership selected Aneth, Utah as one of 3 pilot sites because of its future storage potential. The Aneth site was chosen because of its porous carbonate reservoir, overlain by strong caprock layers, seismic stability, and an existing energy infrastructure. Aneth is also a site where Resolute Natural Resources Company is conducting enhanced oil recovery, which uses CO2 to retrieve oil from a depleting reservoir. In addition to using CO2 for oil recovery, scientists and industry are also able to learn site capacity for CO2 storage. Based on how sound moves through rock, experts are creating an image of what's below, known as a seismic profile. This profile allows researchers to determine if vertical leakage of CO2 would be a problem, thus ruling out the site for potential CO2 storage.
What we're doing today is we are acquiring our second vertical seismic profile. And so what you see here behind me is the yellow truck from Los Alamos National Lab. It is an ongoing monitoring truck. We have geophones, which are highly sensitive microphones cemented into a wellbore, and we are monitoring any minor tremors or seismicity associated with operations here at Aneth.
In order to create a seismic profile, researchers must first create vibrations through the ground, which are then detected by microphones and turned into an image of the rock formation below. This is done with the use of vibro-sized trucks.
The purpose of this truck is to put energy into the ground basically by recreating a small earthquake. What you'll notice is that by the rear wheels, you'll see a base plate. That base plate actually lowers down and couples with the ground. What'll happen when the truck receives a signal to shake, that the mass on top of the base plate will start moving, and all that energy is put into the ground with the base plate. Again, it's like recreating a small earthquake. The whole purpose of these trucks is to basically, they create the noise source, and we measure how long it takes that noise to get from the base plate to our tools downhole. And by doing that, we can help geologists figure out what kind of rock they have based on the speed of sound through the rock.
We're trying to get a picture of the change that's occurring due to injection of CO2. What we do then is we locate those in space, and from that we can infer fractures within the reservoirs that are being accessed by the fluid movement. And that tells us where the fluid's going. It also tells us, is it staying contained within the target reservoir?
The target reservoir is the space designated for CO2 storage in the rock formation.
In this particular instance, this information we're hoping will help us track where the CO2 is going. As the CO2 is being injected into the reservoir, it spreads out, and that CO2 causes the energy to move through the reservoir at a slightly slower velocity. And so as we continue to inject CO2, we'll run these surveys periodically to track where that cloud of CO2 is going, so we can ensure that it is staying in the reservoir.
In addition to ANF, the Southwest Partnership also works in the San Juan Basin of northwestern New Mexico. In the San Juan Basin, researchers are examining a ConocoPhillips site for enhanced coal bed methane extraction. This process is similar to enhanced oil recovery in that it uses CO2 to assist in energy production and has the potential for later CO2 storage. In addition to seismic profiling, the San Juan site provides another example of monitoring technology known as tilt meters. Tilt meters are used to measure small horizontal changes that may occur after CO2 is injected into a formation.
Well, we're a little bit northwest of the injection site. This is a tilt meter. This is one of many in the surrounding area. The tilt meters are going to be used to detect any sort of swelling that may be caused by the CO2. All the tilt meters are in communication with a data shack just a little bit down the road.
Like seismic profiling, tilt meters are used to minimize the potential for CO2 leakage. State-of-the-art safety technology is only part of the story, however. In the end, it all comes back to people who are committed to doing the job right.
But yes, we stay on location. Anytime there's any major operations, we're here. We're on the floor, running casing, cementing. As far as the drilling goes, these hands know what to do pretty much. If they have a problem, they'll come and get one of us, and then we'll help them out.
Through procedures such as these, we are helping to ensure that the southwestern United States can provide safe and permanent storage of CO2.
It's useful information for the Southwest Partnership because they're charged with ensuring that sequestering CO2 is a safe and environmentally friendly operation. And if we can ensure that the CO2 that we're putting in the ground is staying in the layer of rock that we intend to put it in, that will help prove up the sequestering technology.
If you would like more information about the Southwest Regional Partnership on carbon sequestration or about the methods we're using to ensure safe and permanent storage of CO2, please visit our website at www.southwestcarbonpartnership.org.